so this is the activity that we're going to work on today. So you can see that this is like 13 pages long, so it's a much more extensive activity. This first section just goes over practicing removing and stacking the shield, right? Remember we in the actual assembly activity, we talked about using these ring pliers, which is a good way to prevent bending the pins. But if you don't have them, you can manually pull the shield off. Just be careful when you do it so you don't bend the pins, because once you get a few of those pins bent, it can be tricky. All right, so the first thing that we're going to do is we're actually just going to use the GPS in Direct Connect. So the first thing that we want to do, well, we want to make sure our GPS is installed. And then all we're going to do is we're going to open up a blank sketch and we're going to upload that to the Arduino. And one thing to note is we want that switch in the software serial position while we do that, so that the GPS does not mess with our code upload. And when we do that, that should work. And what we're going to do is we're going to open the serial monitor. And if I do that, you'll see that the GPS is outputting a signal. Well, many signals. It's outputting all of these NEMA sentences. So let me quickly just set this up so that we can look at multiple things at once. So one thing, and let me turn my camera on real quick. So this GPS has been sitting here for a while, and I'm in a spot where I can actually get a fix. This is going to be one of the trickier parts about working with this in the lab, is you're sort of limited in what you can do if you can't actually get a fix. It's hard to see if code is working right, but you'll see on the actual fix LED here, that red one that just blinked, it's not blink, I've got long gaps between my blinks. And that means that I have a fix. So if I was to unplug this really quick and power it down and then plug it back in, you'll see that I'm basically blinking my GPS, this red LED. Oh, it got a fix really quick. I may need to actually oh, sorry. I've got the coins. I've got a coin cell in there, so it's actually doing a hot start, so it's able to get a fix really fast. So what's probably going to happen is you're going to start this up and it's not going to get a fix right away. And depending on your lab space, you may not get a fix at all. So that's just something to be aware of. So now if I turn my screen sharing back on and I open up my serial monitor, which I need to do again because it closed once I unplugged it. So let's make sure we have the proper port selected, and let's open our serial monitor again. All right, so you can see here that I'm getting all of these NEMA sentences output. So one thing to note is I've got my I've got my baud rate set to 9600, right? So you can not only get the output of the GPS, you can send commands to it. So we haven't ever really used this in the serial monitor, but you have this text box up here. And if I type a text string in there and I hit send, it will actually transmit that at the baud rate over the serial port. So in particular, if I have the list of commands like we've given you in this table, I can transmit those commands here. So one thing that you want to make sure, I need to be on the proper baud rate. And I also need to, from this drop-down menu, so what this does is basically tells the serial monitor what characters to put at the end of the line when I hit send. And if you remember, I need the new carriage return and new line at the end of my commands. So I want both of those on. And what that'll do is that'll automatically add those. So first, I'm going to turn all of the sentences off so that it's easier to see. So if I copy that bottom string, and I want to make sure that I don't have any extra spaces at the beginning or end, because those will get sent as well. And now if I send this, you can see I stopped getting output because I just turned all of the different sentences off. And if let me change my share so this will show up bigger for you guys. You can see in particular, this last command, this last string that got sent, that's not a NEMA sentence. That is actually the acknowledge from the GPS. So you can see here, it's a PMTK, so it's a, one of those MediaTek packets, and it's 001. And in particular, packet 1 is the command acknowledge. The next thing is what command it received. And if you look at what I sent a PMTK 314. And that matches here. The GPS is saying I received a 314 command. And if you were to look that up in the reference, you would see that that's the command you use to change the NEMA outputs. And then this digit right here is basically a flag that tells me was the command executed. So that has 4 possible values, 0, 1, 2, and 3. 0 is basically that it was an unrecognized command. 1 is that it's a command that was recognized, but it's not supported on this particular type of hardware. 2 is that it was a recognized valid command, but for some reason it failed to execute. And 3 means that it was a command that actually successfully executed. And we can tell that it was a successful command because, the output has stopped. So now I'll want to turn we actually want some output. So if for example, I can turn on only let's go with only the GGA. So if I select this option, I copy it, I paste it into my text box, and I hit send. So you can see there was another acknowledge, and also now I'm getting, sorry. So there was another acknowledge, and then the GGA strings turned on. And you can see that it's only doing GGA strings now. It's not doing all the multiple strings that you were seeing before, right? And this also, it's a lot easier to see what's going on when there isn't like 5 different strings being output and they're all getting, basically you're not getting spammed with a bunch of text. So you can see here that I have my sentence indicator. I have this thing that's ticking up and I'm getting a sentence every second, right? So that's actually just the seconds. This part right here, right before the north, is actually the degrees north, right? And here's my degrees west. And again, that's in that degrees and minutes format. So this is my latitude and longitude. That is the type of fix I have. So I basically have a 2D fix. I can see 5 satellites. And then I believe this, I don't remember this off the top of my head. I think that's speed. Here's my altitude. And then there's the, if you remember us talking about the geoid, there, that's what this second number is. So for the first part, what you guys should do is basically play around with directly connecting and sending commands over the USB. So once that's all set up, we want to swap to the actually connecting it to the Arduino, because basically right now I'm bypassing the Arduino. I'm just connecting directly to the GPS through the USB. So what we want to do, if I stop my share and go back to my camera. So you can see my switch is in the direct, well, it may be hard to tell. So my switch is in the direct position. So if I switch this, what it's going to start doing is transmitting over this jumper right here. And you can see I've got it connected to TX and RX1. And I have the TX of the shield connected to the RX of the Arduino, and the RX of the shield connected to the TX, so that they're swapped, and that this should work. So if I swap this to here, I will now my GPS is connected to serial 1, which is going to allow me to actually do some programming with that. So what this next part of the activity is basically going to run you through setting up, doing the initial setup of the Arduino, or of the GPS. So it's going to walk you through, including the library, defining yes variable. So one thing that we're going to do in here is we're going to define our own command string, right? So since that balloon mode command isn't defined in the library, we're going to do that ourselves. That way we can easily send that command whenever we want to by using this little block of code. Then we're going to set up the variable and the function that we're going to use for the interrupt. We'll set up our serial ports. So in particular, we're going to use serial 0 to send output back to the computer. We are going to put it at a different baud rate. So we're going to need to make sure we match that baud rate in our serial monitor. And then we're going to start our GPS. We're going to send all of our setup commands. And basically there's this block of code here that has all the various options. And what this lets us do is if we want to change the output, we can easily just comment one of these lines out and uncomment another one. And then this will walk through setting up the interrupt. And then finally, the loop is going to be super, super simple. So because the interrupt is doing all the reading, we don't need to like call gps.read. That's happening in the actual interrupt up here. So all that our loop is going to do is basically wait for there to be a new NEMA sentence, and when that NEMA sentence is received, it's going to print it to the serial monitor. So if I pull up that code, so like I said, this activity is going to step you through that part, but I already have the code pre-written. And remember, we have the sample code available for you guys. So if I pull up the right piece of code and I upload this to my Arduino, and I open the serial monitor. So first, you notice this is, you can't see my serial monitor. I'm basically getting a whole bunch of gibberish. And that's because if you look down here at my baud rate, I did not change it yet to match my output. So now that I've done that, I'm getting RMC sentences. And in particular, that's because in that setup part, the line that I have uncommented is the line that turns on only the RMC sentences. So if I leave you guys on the serial monitor here, and I just quickly modify the code by commenting that RMC only line out, and for example, turning on all data, which will output all of the GPS sentences, you can see here that I'm getting VTG, GSV. Basically, I'm getting all of the possible sentences out. So when you guys get to this point, basically, you should play around with sending some of those pre-formatted commands and just work on configuring with the GPS. Now, one thing that you may run into, if you're not getting the output here or on the serial monitor and it doesn't seem like it's working, check your TX and RX connection. So it's fairly common to have these flopped. So where you have like TX connected to TX and RX connected to RX, and that's not going to work. So usually that's the first thing you want to check if it's not working for some reason. If you're sure you've got it connected properly and it's still not working, well, then you probably maybe want to pull out an oscilloscope and make, basically connect it to the little points here so that you can tell if it's actually transmitting the signals. Also, obviously, make sure your switch is in the right position. And the final section of this activity is going to walk through using the parsing function. So first, so basically all of the setup is already done. So the first thing that it's going to do is basically all we're going to do is call parse. And when it successfully parses, because one thing this parse does, besides actually breaking up all the data, is it'll return a true or false value on whether or not it's successfully parsed. So if I modify my loop to include, do this little bit of code, it will basically output a little message, and it'll output the sentence every time it successfully parses. And obviously, so depending on what sentences you have on, I will get more than one of these messages every second, right? Because this should execute every time we actually get a new NEMA sentence. So if I have multiple sentences on, all being transmitted once a second, if I have like 2 sentences on, I'll get 2 of these a second. If I have 4 on, it'll get that. So next, after that, we're going to work on using some of these actual variables. So we're going to basically show how to get the seconds, and then we're going to build a little timestamp here. So hours, minutes, and seconds from the sentences. And then finally, the last thing you're going to do is you're basically going to output the different parts of data at different time intervals. So this will walk you through setting up a timer that will basically execute every 5 seconds. And you'll only output a certain chunk of data every 5 seconds. And then after that, you should work on basically doing the same thing, but every 7 seconds and every 13 seconds at different intervals. So one thing to realize is if you really want to figure out if you are able to get a fix wherever you're working. Obviously, it's a lot harder to do this when you don't have a fix. You should at least get a timestamp, even if you don't have a fix. It's just it won't be accurate. It'll basically start outputting times at midnight 1970 and counting up from there. So even if you aren't able to get a fix in your lab where you're working, you should be able to get timestamp